Hello everyone. Welcome to the lecture series on Foundations of Deep Learning, Concepts and Applications. This is the first lecture in our series, and today we will begin with a brief look at the history and evolution of artificial intelligence and deep learning over a period of time. We will also look into how the technological improvement in computers, hardware part, helped in the evolution of AI. After that, we will go to an overview of machine learning. We will first discuss about the distinction of machine learning from traditional programming approach, followed by an exploration to the various machine learning techniques and their applications in solving real-world problems. Subsequently, we will move towards deep learning, examining how it is different from machine learning approach and why it has become such a transformative technology. By the end of this session, you would be able to appreciate the significance of deep learning and its wide-ranging applications in advanced technology. Without further ado, let us go to the overview of machine learning and deep learning. I will move into the contents for today's lecture. We'll start with history and evolution of AI and deep learning, then go to introduction to machine learning, difference between traditional programming approach and machine learning approach, type of machine learning techniques we will explore, under which comes supervised learning, unsupervised learning and reinforcement learning. Then we will go to introduction to deep learning, difference between machine learning and deep learning, and finally applications of deep learning. So let's start with the history of AI and deep learning. The journey of AI started some 80 years back. It started from 1943 when McCulloch and Pitt created the first artificial neuron, planting the seed of AI. Then came the Turing test in 1950, where Alan Turing asked the famous question, can machines think? Soon after, in 1950s to 1960, we entered the first golden age of AI when the perceptron and the adaptive linear neurons were introduced, and researchers believed machines could soon learn like human. But then came a setback, the XOR problem in 1969, which proved that simple network cannot solve complex tasks. So from that time began the AI's first dark age. Still the dream haven't died. And in 1980s, with the idea of backpropagation, it led to the second golden age. Models like neocognitrons and CNNs emerged, showing that computers could recognize patterns and even read handwritten numbers. In 2000, from 2000 onwards, it saw a steady progress, and in 2012, AlexNet changed everything. It could recognize images better than ever before, kicking off the deep learning revolution. And from 2017, the transformer models were introduced, and from there it came GPT-3, ChatGPT, GPT-4, which could understand and create human-like text. And now in 2025, with DeepSeek R1, we are actually standing in the third golden age of AI. Now we will see how the evolution of computer hardware also helped in the evolution of AI. In the earlier eras, the processing speed and the CPUs that were available, the memory sizes that were available with computers were low. And that is the reason only very basic AI algorithm processing was possible. But in today's technology, due to the advancement of processors, due to the lot of memory available for processing, the AI research is going in a much faster pace. As hardwares improved, faster processors, large memory made it possible to handle more complex algorithms and bigger data sets. So this rise of GPUs and TPUs allowed machines to train deep learning models much faster. Then we will come to what is machine learning. Machine learning is a subset of AI that enables system to learn from data. Machine learning is the first field of study that gives computers the ability to learn without being explicitly programmed. Now what we will see is what is the difference between machine learning and traditional programming approach? We will see if there is a task that is given to us, how traditional programming approach will solve that problem and how this problem will be solved from machine learning approach. Suppose we take a problem statement like whether a patient is having ovarian cancer or not. So this is the problem statement that we have in hand. Now in traditional programming approach, the diagnosis will be based on a fixed number of rules. So if tumor size is greater than 5 centimeter and CA level is CA125 level is greater than 35 and irregular shape on ultrasound, it is likely to be cancer. That means these rules, there are a set of fixed rules which governs that whether a patient is having ovarian cancer or not. But what happens is these symptoms and test results vary widely between patients, and it is impossible to write down all the possible rules to detect it accurately. It's a limitation. Now we will come to see how machine learning approach handles this kind of problem statement. So in machine learning, what happens? We train a machine learning model using medical data from many patients. So in that medical data, what are the things that we look for? We take imaging data like ultrasound, MRI, blood test markers like CA125, the patient's age, the patient's diagnosis, cancer or not cancer, the previous history, all these things we will take as a patient data, and a machine learning model will be trained on the data that are common among patients who had cancer, so that when a new patient's data is given, the model can predict the likelihood of cancer. So this is the main difference, where we are not setting a set of rules like traditional approach, but in machine learning we are taking the data of patients coming from various demography, age, with various history of illness, and then we are training a model with all this data so that the machine gets the training, and based on that training, when a new patient's data is given, the model predicts whether there is a likelihood of having cancer or not. Then we come to types of machine learning technique. In machine learning technique, we have three major categories of algorithms: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we have classification and regression. In unsupervised learning, we have clustering, and in reinforcement learning, it is all about learning from the feedback from the environment. We will see little more in detail in the coming slide. So we come to supervised learning. In supervised learning, we train a machine learning model with something called as labeled data set. So suppose consider we have this set, a rectangle, some triangles, some circles, and some hexagons. And if we can label them, that means give a name like this, like a square shape is a rectangle, then the three sides shape is a triangle, then circle and hexagon, then that training data set becomes a labeled data set. And this labeled data set, when we give to a machine learning model, what happens is it learns that, okay, this is, if it is having 4 sides, it is a rectangle. If it is having 3 sides, it's a triangle. If it is having 6 sides, it's a hexagon, and so on. It's like teaching a kid that, okay, this is A, B, C. Over a period of time, you show the letter alphabet A, B, and C to this child. After 7 or 8 days, you show the letter B to him. He will be able to recognize. So it is called as supervised learning. You are supervising the learning process. And when you send this labeled data into the machine learning model and train it, after that you give some test data like one triangle and a hexagon without giving the label, then it gives it's a triangle, and this is a hexagon. So this is supervised learning. Coming to unsupervised learning, what exactly it is? So here we have the same set where we have hexagons, rectangles, triangles, circles, but they are not named. Which one is a rectangle, which one is a circle, which one is a triangle? There is no label that is attached to these items. There is a mixed set, and which we are giving to the unsupervised learning algorithm. This unsupervised learning algorithm, what it does is, it tries to learn a pattern, a hidden pattern from this data, and then it clusters or groups these input data into different clusters. Like, it will tell these are the green ones are looking similar, the red ones are similar, the blue ones are similar, and the yellow ones are similar. Then coming to something about the reinforcement learning. What exactly is the reinforcement learning? Reinforcement learning is nothing but basically learning from the feedback that an environment gives to an action taken. See, here there is a cartoon in which a robot is there and it is having two things in its environment. What are the two things that are there in this environment? One is a tap from which water is falling, and there is another one that side which is a fire. So this comprises of the environment, and the agent is the robot. Now the robot is thinking whether I should go towards the tap or the fire. It is observing the environment and then it is selecting an action using the decision called as the policy. So we call it as a policy, where it takes a strategic decision to go either towards the fire or towards the water. Now what happens is, when it goes towards the fire, it gets hit, okay, because that high temperature is hurting him. So he gets like, okay, oh, this is not good for me. So he gets some feedback from touching the fire, which is equivalent to some negative points. So next time, based on this learning, he will not go towards the fire. He will choose the path where he will not get negative points, but he will get some rewards. So this is all about reinforcement learning. So after every action, there will be either a reward or a punishment given to the agent. If he gets a reward, he will follow that path. If he gets a punishment, he will reiterate and then he will go to he will take some other decision. So this is learning from the feedback in the environment. This is about reinforcement learning. Then we come to applications of machine learning, a quick look. So we all know supervised, unsupervised and reinforcement learning. Just now we have seen. And in supervised learning, we have two basic algorithms like regression and classification. In regression, we predict some values, and in classification, as the name suggests, we classify some items. Okay? So for example, weather forecasting is an example of regression problem, where we want to predict what will be the weather in the next few days. Whereas in classification, maybe diagnostic, whether an MRI scan or CT scan is showing some tumor or not inside the human body. Yes, tumor is there, no tumor is not there. So that kind of thing is a classification task. Then in unsupervised learning, we learned how the clustering happens, and this clustering is used in various kind of recommended system, targeted marketing and customer segmentation. So based on whatever previously we have given our history, there is a recommendation that comes in the system. Okay. So that is called as clustering algorithm. Like, Netflix gives recommendation for movies. It is based on whatever we have seen before, and then it has if I am seeing more number of Hollywood movies, then it will put me in a cluster where there are audiences who watch Hollywood movies, and then next time it recommends me, it will recommend based on the history that he is having from that cluster. So he will see that, okay, this person belongs to an audience, target audience who are watching Hollywood movie. So let us recommend some Hollywood movies to her. So this is the way the clustering algorithm works. And in reinforcement learning, we saw that it is based on the feedback that we get, and it is used in gaming AI, robot navigation, real-time decision making, like this kind of applications. Now we come to deep learning. Now what is this deep learning? It's a subset of machine learning based on artificial neural network. Now we'll keep on hearing this term artificial neural network in all our subsequent lectures, and that is the building block of deep learning. So what is this artificial neural network? It is nothing but a mathematical model of the neurons or the network of neurons that are present in human brain. And it mimics how activities happen in human brain. The similar things are mimicked in artificial neural network. It is inspired by human brain. And what is the most significant part of this deep learning? It can handle large and complex data sets, including image data, speech data, text data. Okay? And if we want to see where exactly this deep learning comes in the overall umbrella of artificial intelligence, we can see here that artificial intelligence is the main umbrella, under which there is machine learning as a subset, under which deep learning is a subset of machine learning, and within deep learning, generative AI is another subset of deep learning. Now we would like to see what is the difference between machine learning and deep learning, why we needed to go to that one. Now for understanding that one, let's take a problem statement like an image classification problem, where you have the image of a puppy and you want to classify it as a dog or a cat. So that is the problem statement we are having in hand. Now we will try to see how machine learning approach deals with this problem and how in deep learning what exactly happens. In machine learning, human first extract features from the image, like the color histogram, age detection, texture patterns. That means a human will see what are the significant features of a dog. Like it will have, this long kind of ears, the eyes will look like this, then it will have a furry texture, and then there will be some pattern of color. So color may be a little, a brownish in the face, little lighter, in the neck portion, whatever. So there are features which are handcrafted by human. Whereas in deep learning approach, we have something called as the convolution neural networks, which we will study in our subsequent sessions. The convolution neural network is trained directly on the raw images, with the pixels giving information about the color and intensity that is present in that pixel. Now, in machine learning approach, what happens is, once human extract the features that, okay, these are the things which should be there for an image to be a dog's image. These features are fed into an algorithm like support vector machines or random forests, and then what happens is, from there it does the classification. Whereas in deep learning approach, the network automatically learns hierarchical features. Hierarchical features means it will first learn to detect the edges, like the edges of the dog's image. Then it will detect, okay, this is an eye, this is a nose, this is the ear, this is the tail, this is a furry pattern, and finally it will identify it as a cat or a dog. So in neural networks, particularly in convolutional neural network, what happens is the first layer, there are multiple layers. In the first layer, it detects the edges. The middle layers, it detects the eyes, furs, patterns, etc. And final layer, it identifies whether it is a cat versus dog, whether it is a cat or a dog. Okay. Now, the machine learning approach will do very well if the features extracted by human are well done. So, there is a dependency of human in the overall result that we are getting from the model. Whereas, in deep learning approach, no need for manual feature extraction, model learns everything from the data and it is much more automatic. So, here the expected results are much higher because it is automatically the layers are learning. Now, finally, we will come to the applications of deep learning. There are various applications, and in today's world, we cannot think lot of things without deep learning. So, coming to the various applications of deep learning, there is self-driving cars, language translation, automatic text generation, speech recognition, facial recognition, virtual assistants, fake news detection, image captioning. All these are just a small subset of where all deep learning can be used. So, with this one, I come to the end of today's session. So, let's have a quick summary of what all we have learned in today's session. So, we started our session with a brief history of the evolution of AI and how computers' evolution also helped in progressing AI research. Then we looked into what is machine learning, how it is different from traditional programming approaches. And then we saw the various machine learning techniques, supervised and unsupervised reinforcement learnings, and the different algorithms coming under supervised, like classification, regression, unsupervised clustering, and reinforcement learning, which is driven by the feedback from the environment. Then we saw what exactly happens in supervised learning, what are labeled data set, how the training happens in supervised learning, in unsupervised how clustering happens, what type of data is given in unsupervised learning, and what exactly is reinforcement learning. Then we looked into the various applications of this machine learning technique, like machine learning regression, for what kind of applications we use regression, like weather forecasting or market prediction. Classification helps in diagnosis, medical image classifications, in any classification work. And then we saw unsupervised learning, it helps in lot of recommended systems and customer segmentation based on whatever data they have. Okay. And then in reinforcement learning, we have seen that whether they can be used, or actually they are used in gaming AI and robot navigation and other stuff. Okay, decision making, real time decision making applications. So then finally we came into deep learning and we saw how deep learning is different from machine learning and what are the different applications of deep learning, why it has such a significant take in the advancement of technology. So we saw the difference between deep learning and machine learning and looked into a handful of applications that are that we see in our regular days, which are helped by deep learning. And with that one, we come to the end of this session. I trust that you have found this information engaging and helpful for you. Thank you all for joining us. Next time we will explore on single layer perceptrons, which is the starting of neural networks. Until then, take care and keep learning. Thank you.